Okay, so thank you everyone for coming to this virtual seminar series. And I am Xiaoli Nan. I'm the director for the Center for Health and Risk Communication here at the University of Maryland. So we host CHRC. This is our CHRC virtual seminar series, and we do that 4 times a year. We do that twice in the fall and twice in the spring. We feature some of the most accomplished as well as emerging scholars in risk communication, broadly defined. So we feature health comm scholars, risk comm, science comm, and environmental communication. So I'm most pleased to introduce our speaker today, Janet Young. I haven't actually personally met Janet, but I have heard so much about her, especially in the area of risk communication. And I got a lot of requests to feature Dr. Yan in our series. So finally, we get a chance to have her on our seminar series. So I'm really pleased. So Dr. Yan is a risk communication expert who conducts social scientific research on the cognitive and emotional determinants of risk perception, information behavior, and strategic messaging. Dr. Yan has published over 90 peer-reviewed journal articles and delivered over 100 presentations at international conferences. Some of her recent projects examine public risk perception and communication behaviors related to the COVID-19 pandemic, vaccination, climate change, air pollution, and PFAS contamination. You know what? This might be the first time I heard about the term, so I really look forward to learning more about it. Her research has been funded by the National Science Foundation, the Leukemia and Lymphoma Society, New York State Department of Environmental Conservation, among others. Dr. Yan's research has been covered in national and international media outlets, such as the New York Times, BBC, NPR, and the Smithsonian Magazine. She was awarded the 2021 Chauncey Starr Distinguished Young Risk Analyst Award by the Society for Risk Analysis and the 2020 Healer Grayborn Under 40 Award by the Association for Education in Journalism and Mass Communication, commonly known as AEJMC. So today, Dr. Young's gonna give a talk on risk perception and risk mitigation behaviors related to PFAS contamination. So without further ado, I give you Dr. Yan.
Thank you so much for that very generous and kind introduction. I was just thinking about the same thing that I heard your name, Xiaoli, so many years. I just never had a chance to meet you in person. So I'm glad we were able to connect through this virtual platform. And thank you guys so much for making the time to come to this talk on a Friday afternoon. It's a beautiful fall day here in Buffalo in the 70s, which is very surprising. So today I'm going to talk about PFAS contamination and risk communication strategies related to this emergent environmental and health risk. But before I get started, just now Xiaoli provided a very thorough overview of my research program, but I wanted to just talk about two general lines of work that I've been doing over the last 10, 15 years. So as Xiaoli mentioned, my fundamental question is to look into both cognitive and emotional determinant of risk perception, and also more importantly, how risk perception influences our communication behaviors and also more downstream effects on policy support, preventive behavior formation. So my work has been both theoretical, but also practical for a lot of the reasons that, many of the risk contexts that we deal with have real world consequences and implications, right? Which is why my work has been very fortunate that I received funding from both federal agencies and also New York State government agencies to identify effects strategies to talk about a lot of those, environmental health problems. Most recently, my work has been funded through a $4.5 million grant from the New York State DEC to look at recycling and reuse, which are typically, we don't think of them as risky behaviors, right? Those are pro-social, pro-environment behaviors, but we actually found across different contexts, there are some very fundamental theoretical frameworks that really help us to understand better about human behavior. So over the last decade or so, I have done a lot of work related to the risk information seeking and processing model, which many of you might be familiar with, specifically both contributing to the theory, but also evaluating as its entirety in terms of its theory implications. I have looked at both using the model, but also expanding and refining the model to account for different types of information behaviors, including information seeking, avoidance, information processing, and also information sharing. The second line of my work, actually, I have applied quite a bit, and I know, Shelley, you have done some work on control level theory as well. So we published about 15 articles looking at control level theory of psychological distance and applying this particular psychology theory to identify strategic messaging strategies to talk about, for instance, climate change and aquaculture, which is another interesting topic that many of you have probably heard very little about. So our contribution specifically is to look at the role of control level theory and how it's been connected to discrete emotions, and also applying the fundamental principles of control level theory into narrative persuasion to look at how it might be useful in getting people to not only pay attention to specific risk issues, but also consider perhaps modifying their existing behaviors and changing attitude. So before I dive into PFAS, I also want to acknowledge very quickly my collaborators over the years, right? Because without them, I wouldn't have been able to do a lot of the things that I was able to do. Specifically, Dr. Laura Ricard, who is associate professor at University of Maine, Dr. Robert Griffin, who was my advisor and also professor emeritus at Marquette University, my current colleague, Dr. Tom Philly, professor of health communication, and lastly, Dr. Leanne Kaler, who is a professor at UT Austin. And I know some of my graduate students or former graduate students are in the audience, so I definitely want to acknowledge a lot of their contribution to my work. The 5 ones you see on the top are students who have already graduated. Many of them hold tenure track professorship, assistant professor positions, and associate professor positions at different institutions. And then Prina Shah and Ms. Xinsha Dong are my current PhD students. So without further ado, let's talk about PFAS. So many of you probably do not know much about PFAS. It is one of those emergent environmental health risks that is very under-researched, especially from a social science standpoint, but it's ubiquitous. It's literally everywhere in our environment. So PFAS has this interesting name commonly known as forever chemical because it is a very stable chemical composition. Once it's released into the environment or into human body, it basically stays there for a very long time. It's very difficult to break down. So as you can see on this infographic, forever chemical, because it can take up to 1,000 years to break it down in nature, right? Which obviously is concerning because a recent study from the CDC found that over 98% of Americans actually have it in our blood serum, right? So it's already in our physical body. Some of the health impacts that PFAS, I guess, exposure has been linked to, including cancer, reproductive issues, lower birth weight, and another study that's fairly recent actually found people who have high level of PFAS in their blood serum, they tend to respond less to COVID vaccine. So there's a lot of essentially health implications here. And I just said that PFAS is ubiquitous, right? So on the left-hand side of the infographic, you can see we could potentially be exposed to PFAS through drinking water, through milk consumption, because a lot of the PFAS actually gets into our soil, gets into food supplies for animals, which essentially get transported into milk products as well. Some of the things that you probably have heard about being linked to PFAS is the nonstick cookware, right? So the Teflon pan, which was originally where the whole problem of PFAS came to public attention in the first place. But many other sources could also include stain-resistant clothing and carpet, some food packaging materials. So think about pizza boxes. Think about your fast food with that tin foil in there, and also microwave popcorn. So essentially, we have a lot of different ways that we come into contact with PFAS, which is why I think this is a very interesting emergent area that definitely needs more research. So our goal to look at risk communications specifically linked to PFAS is, very much focused on this potential exposure and think about how we could communicate more effectively to help the general public understand about PFAS. So this map on the left-hand side here essentially shows the states that have concentrated level of PFAS in drinking water, right? So New York, North Carolina, California, and Michigan are some of the states have very high level PFAS concentration in our water supply, which essentially, sorry, did I have oh,
Duncan, please mute your speaker. Okay, thank you.
okay, that was the question, sorry. So, this level of concentration in our water supply essentially is the main reason that led the Biden-Harris administration in 2021 to launch a general plan to combat PFAS pollution, initiating basically a joint effort from the EPA, from the CDC and FDA and multiple government agencies to look at both the environmental front, the health front, the epidemiological front. So many agencies working together to figure out what we can do as a nation. So specifically today, I want to talk about two projects that we have done. The first one looked at experimentally how personal relevance influences communication behavior, specifically information processing and information seeking intention. We evaluated essentially how does a message exposure influences those communication behaviors through both risk perception and also negative emotions. And also because PFAS is a very scientific, risk topic, we also looked at the role of institutional trust to look at how that potentially also contributes to the way that the general public seek and process information about this topic. And the second study, more recently, we also looked at more downstream effects. Essentially, how do communication behaviors contribute to both policy support and the formation of preventive behavior intention? We have 4 articles that are published to date, 2 of the studies I'm presenting to you today, and also 2 additional ones that, you're more than welcome to ask me for copies, and I'd be very happy to share with you. So the first study, we focused on this concept of personal relevance. Not surprisingly to many of you who have, studied due process models such as the heuristic systematic model, we know that personal relevance is one of those key motivational factors that influence information processing behavior, right? So in this first study, essentially we devised an experimental design to either increase or elevate personal relevance or reduce that hope that personal relevance is at baseline level to look at how those information exposure influences information processing strategies. So specifically in October 2021, we recruited a sample from Research Match, which is essentially an online platform that offer free participants, US adult participants. And because it's free, as you can see, our sample is definitely not representative in a lot of those specific demographics, right? So this particular sample, we have more female, it's definitely older, a little bit more white, and more education, higher education compared to national statistics. Household income is actually fairly similar to census data, and our political ideology-wise is a little bit also more conservative leaning. So because we have an experimental design, a lot of those demographic issue, we're now trying to assert any kind of generalizability to the overall population, just to make sure that's clear. But let me tell you what we did. So as I said, it's a pretty simple one-way design. So we randomly assigned participants into 2 conditions. In one condition, it read a very simple text that explains what PFAS is, right? What does it stand for? And also some of its presence, or I guess chances that people could be exposed to PFAS through consumer products, right? So we talk about nonstick cookware, your pizza delivery box, and also your stain-resistant carpet. And then, because before people were exposed to this message, we also asked about their zip code, their home address, right? It's kind of not linked to the message exposure at all. It was done in a very early stage of the study. But when they were exposed to the message, we told participants, based on the zip code that you reported, your residential area has high level of PFAS contamination in drinking water. Obviously, it's for manipulation purpose, and we fully debriefed our participants after their participation in this study. In a low relevance condition, we basically told participants that their residential area does not have high level PFAS. We also linked or explained that PFAS primarily exist in industrial products such as metal plating and construction materials. So after this exposure to a very simple, messaging, what we did is to essentially measure some of the key variables, such as risk judgment, institutional trust. We measured both trust in government as well as trust in science. We measured 5 different discrete emotions, all negative, including, anger, sadness, distress, similar emotions in that nature. We also measured systematic processing. Essentially, when it read the message just now, right? How did they process this information? Did they read it carefully? Did they think about how this information is relevant to other things they know? Did they think about how this information is, important for they themselves? We also measured information seeking intention, pretty standard measures. Are you likely to want to seek information about PFAS in the next, 3 months? For our manipulation check, we have done pilot work on this study among a student sample, and in both the pilot study and also in the main study that I'm showing you here, we found that the manipulation was definitely successful. People who read the high relevance condition reported that they thought the message they read is very relevant to them, higher than people in the low relevance condition. So what we found, we analyzed data through structural equation modeling, using personal relevance as our exogenous variable and including risk judgment and emotion as 2 mediating factors. Trust, institution trust, as I said, both in science and in government, were also included as exhaustive variables predicting systematic processing. So what we found, essentially, not surprisingly probably, is that when people were exposed to the high personal relevance condition, their risk judgment was elevated, right? They reported higher risk judgment, which also led them to express stronger negative emotions when they think about PFAS contamination. And those two mediate this pathway from personal relevance to systematic processing. As you can see on the upper right hand, the indirect effect through 2 of those mediators was also significant. And interestingly, we found that between trust in science and trust in government. Well, I guess that's the joy of
that's adorable.
So trust in science was positively related to systematic processing, but not trust in government. I did want to point out that trust in science and trust in government, those 2 were correlated, but only at 0.25, right? So they were not very highly correlated in this particular research. Interestingly, people who processed the message that we gave them to read more systematically, they also indicated a stronger intention to seek more information in the future, which is the 0.73 beta coefficient that you can see towards the right-hand side of the model. And there's also a significant mediation here from relevance to systematic processing and then explaining information seeking intention in the future. So down below in the table, you can see that both the measurement model and also the structural model fit the data fairly well, with all the indicators or indices falling to acceptable or excellent criteria for SEM analysis. So generally what we found in the first study, personal relevance indeed is a very crucial factor that influences the way that people process a message that's specifically related to PFAS contamination, which suggests that in terms of strategic messaging, right, it could be very important to highlight local impact and also those quotidian experience that people might come into contact with PFAS to increase the sense of perceived relevance. It's not just one of those, chemical external out there we don't need to be worried about. There's actually a lot of different ways that people can be exposed to it. Probably all of us as everyday, consumers and ordinary citizens, we should pay more attention to this issue and perhaps also demand more government action in terms of preventing and protecting citizen and general well-being and health. And second of all, we did find something that's very much consistent with NABI's functional cognitive model of emotion. Emotion can serve as a very important informational cue to influence information processing behavior. And lastly, this very interesting differences that we observed between trust in science and trust in government alerts us to really think carefully about institutional trust as a concept, especially because, as we all know, Americans' trust, especially among conservatives, has been declining over the years, especially trust in government institutions, which suggests that when it comes to something like, PFAS contamination, we definitely need to identify those, trusted spokesperson to unique and specific communities to really help with the communication effort, right? And here, one good thing I want to point out is that, Pew data has indicated, even though trust in science has been declining, generally, most Americans still find scientists to be much more trustworthy as compared to government officials, right? So in that notion, perhaps university scientists and scientists that specific, segments of population might find trustworthy or credible could probably serve as more useful spokesperson for this particular issue. So this article just came out this year in JOHC. As I said, you should be able to find a copy, but if you want to read more details about this study, I'll be more than happy to share with you as well. So moving on to the second study, that's where so we know there are ways we can get people to process information more systematically, more carefully, and perhaps also want to seek information in the future about PFAS contamination. But obviously a bigger question here is that, so what, right? Why do we care about communication behaviors? Do they actually do anything to engender greater policy support and perhaps getting people to consider changing their existing behaviors, right? So in a second study, we did a follow-up, but kind of follow-up because we also measured, risk perceptions, emotional responses, and a lot of those variables that I mentioned just now. But what we did is to recruit a separate sample from Cloud Research, which is, MTurk's platform that's more for participant recruitment for research, for social science research specifically. This sample definitely matches census data a little bit more closely as compared to the first study. We have a pretty gender balanced sample. Age, race, and education are all fairly similar to census data. The household income is definitely lower, right? I think currently the census data is about 74,000 for general household income in the US. So we definitely have a slightly lower income participant pool. In terms of ideology, it's fairly middle. So it's a 7-point scale from liberal to conservative, a little bit more liberal leaning. So this study is very much conceptualized based on the general, assumptions behind the risk model, which is shown on the right-hand side. I'm not going to go into the nitty-gritty of all the risk idea because this is not really a straight up theory testing based on the risk framework. But I do want to point out that, the fundamental questions that we're interested in exploring in this particular research is to look at, what the risk model argues essentially is that information insufficiency, which is this idea that taking into account how much we currently know about a risk topic, those individuals who have a greater need for information sufficiency, they're much more likely to engage in systematic processing and also seek information more actively, right? So we did measure all the key concepts from the risk model, but today I'm going to focus on sharing with you specific results that we found linking to policy support and behavior intention. So specifically, because PFAS, as we have established in the first study, it's a low awareness issue. Many people don't know much about PFAS, which is actually something we observed in this data set as well. If you look at on the upper left-hand side, when we asked people their general current knowledge about PFAS, people reported about 16.7 as a mean, which is really low, right? Essentially, people don't know much about this topic at all. And here we did not give them anything to read, no exposure. It was really just a baseline evaluation of how much do this very, non-representative convenient sample of Americans know about PFAS. When it comes to information sufficient, the threshold, it reported about 60, right? That's the average. So people definitely want to know more, perhaps just because, anytime you hear another environmental risk or a new chemical, people do have this general sense of curiosity. They want to find out more about it, right? For our most important outcome variable, we asked the participants about their policy support, including setting restrictions on manufacturing and importing PFAS, and also setting maximum permissible level PFAS in both food and drinking water, which actually has a very important takeaway, and I'll talk about at the end of my talk. For behavior intention, my graduate students worked very diligently to identify existing recommendations from the FDA and from the CDC, but all the 8 items that you see here are primarily designed based on the latest FDA recommendation or guideline for consumer behavior. So including things like avoiding microwave popcorn and avoiding oil and water resistant food packaging, and also probably check labeling for specific ingredients that start with, PTFE. Obviously, we understand that's asking a lot for consumers, right? But as I said, this is the first attempt to come up with a set of measures that could help us to understand preventive behaviors. Fortunately, both policy support and behavior intention achieved decent level of reliability in this particular research. So what we did analytically essentially is, after controlling for all the key demographic variables, controlling for all the other predicting variables in the risk model, we really focused on evaluating, right, controlling for everything else. Did information seeking, information processing contribute to policy support and behavior intention? All right. So what you can see is they did. In terms of overall beta, they ranged between 0.23 to 0.33 between both seeking and processing behaviors on policy support and behavior intention individually or respectively, right? And in terms of R-square, the overall model was able to account for about 40% of the variance in both policy support and behavior intention. So to summarize, like I said, risk communication behaviors are definitely very important impetus for policy support and behavior formation, which is something we know in risk communication research related to many specific topic areas. But in this particular study, what we found also is that linking to policy support, right? Systematic processing, information seeking are both crucial, but more importantly, we also found that risk perception, trusting signs, once again, and also emotional reactions, they are all positive predictors of policy support. Obviously, with cross-sectional data, we're not making any kind of causal claims, but those are essentially some of the very important factors that seem to account for policy support beyond, the influences of some of the demographics and baseline knowledge. For behavior intention, here is a very interesting contrast. We did find that risk perception and information seeking processing are positive predictors of behavior intention. But further, we also found that informational subjective norms, which is this idea that if you think other people expect you to know something about PFAS, you're more likely to indicate that you want to engage in preventive behaviors, right? And lastly, this personal efficacy concept, which I haven't introduced up until now, but we did measure for, essentially, do people feel that it's just too much, right? Because I think a lot of consumers do have this complaint about scientists. We see risks everywhere, right? There's always another new thing that we need to be aware of and we need to worry about and we need to do something about. So in this study, we did measure this concept of personal efficacy. Essentially, do you think you're capable of doing something, right, to reduce your or your family's exposure to PFAS? So this particular variable also is a very important predictor of behavior intention, which is definitely consistent with all the, behavioral type of theories that we have known, such as the theory of planned behaviors in risk communication research. So this one also came out in JOHC, not by design, just happened to both get published in the same journal. And my student Xinxia is the first author on this piece, and I know she's in the audience, so I want to give her a shout out. So the general takeaways and the next steps, right? So first of all, PFAS as a emerging environmental health risks, we definitely have a lot that we can do, right? Most recently, all the studies that we have done, essentially personal relevance, risk perception, emotional responses, those all offer, individual key insights when it comes to strategic messaging design. So as a very important and new development on public communication surrounding PFAS, I want to draw all your attention to something that happened in 2022. So the EPA just released a new standard for highest level acceptable level of PFAS in drinking water. That's a new advisory that they just released, right? But immediately there has been a lot of disagreements among university scientists, especially because the standard that the EPA released essentially is not really detectable based on existing chemical instruments. And essentially, university scientists are arguing that you can set the standard at this particular level, which is 0.004, which essentially scientists cannot really discover or detect it, right, realistically or effectively. So some scientists are really concerned about this new EPA standard, saying that is it just for show, right? If we can't really detect this level of concentration in water supply, what is the point of it, right? So right now, as a next step, we're actually in the process of working on several experiments looking at different type of potential conflicting information, right, surrounding PFAS contamination and how that influence or perhaps offer, confusing messaging to consumers and the general public, which, as we know from risk communication research, when you have conflicting information or going back all the way to this idea of false balance in journalistic media coverage, it could have a lot of very negative consequences on public trust and also risk perception and downstream mitigation type of behaviors. And the second project we're working on right now, also experimentally, we know that, going back to due process models, such as the HSM, the systematic model, motivation is one part, but capacity is also really important, right? Especially when it comes to science and risk communication. Many of the things that are surrounding emerging risks like PFAS requires a certain level of literacy or numeracy to understand and process that information. So we are in the process of analyzing experimental data where we either increase or decrease processing capacity, essentially by giving people a more difficult text to read or a fairly approachable, easier text to read about PFAS, right? And keeping everything else consistent. On the reading level of difficulty, we actually did find some initial evidence that it matters quite a bit, which influences, subsequent information processing strategies that people engage in to deal with that information, right? So those are all the things I have on our initial, I guess, research program looking into PFAS contamination, and I will welcome any question from the audience. Thank you very much.
Awesome. Thank you so much. We do want these seminars to be very interactive and so that's great. Janet is giving us quite a bit of time for Q&A. So I have a number of questions, but I'm gonna give the audience members the chance to ask questions. You guys feel free to maybe raise your hand. I can see you, or you can type in your questions in the chat. We'll take a couple questions and hopefully we'll engage in a really interesting conversations about this phenomenon maybe many of you haven't heard about. Okay. So I think when you guys are formulating your questions, okay, we got Isabel. Oh, this is a student from my class. Excellent, Isabel, good to see you. So Isabel asked, why did you choose to research PFAS? And how did you find out about this forever chemical?
Oh, interesting question. I guess I need to kind of reflect or revisit, just refresh my memories about how I became interested in this in the first place. Oh, I remember. So 2019, there was a movie called Dark Waters. I don't know if anybody has seen the movie. Mark Ruffalo, I think, is the Hollywood actor that portrayed the lawyer who started the original lawsuit against DuPont, right? DuPont is the chemical manufacturing corporation that came up with PFAS. They essentially identified or found this chemical that is very stable. Obviously, stability for a chemical a compound is very useful in a lot of ways, right? So they put that into Teflon, this non-stick pan, and many American families purchased it. And so DuPont actually found back in the 50s, I believe, that PFAS leads to a lot of health issues, linking to cancer, linking to reproductive issues, but they were essentially kept this off public record, right? So they've known this for many years, but they never released it, never warned the public, and they never did anything responsible to take it off market. And what's worse was that they actually dumped chemical sludge in the rural agricultural community in Ohio. So essentially, local residents were exposed directly to this horrible chemical. So the movie essentially portrayed very realistically that whole experience of suing DuPont. His life was threatened. It's a thriller, right? It's a Hollywood dramatization of the incident. But when I watched that movie, I got scared a little bit, right? Because I just had my young kids, 2019, so they were 3 and 6, right? And in the movie, they shown the horrible impact on children, right? Their teeth was black, and a lot of it's very visual and very vivid. So immediately, as a caretaker, as a mother, right, I was like, I better look into this thing. I got rid of all the nonstick pans in our household. Our whole household, literally, we bought new pans, and I started to read more and more into this. And also the other part of it is that there's a chemistry professor in my institution, Diana Aga. She's very accomplished, very productive, and we started talking about PFAS. It turned out that her lab has been doing a lot of work in the detecting part and also the mitigation part, right? To essentially figure out chemically, how can we break it down? Is it possible ever to break it down? Or maybe certain type of PFAS are easier, but not others. So conversation also started from there, right? They're doing on the chemical front, and I'm trying to figure out, in terms of communication strategy, what we can do. So we submitted couple proposals. To date, hasn't been funded yet, but we're still in the process and hoping to submit another proposal to the EPA by this December, trying to work together essentially to figure out some solutions, both scientifically and also from the communication standpoint. So thank you for giving me the opportunity to reflect on all this. I think we have another question.
Yes, yes. I think we have another a comment. Lonnie, do you want to speak up, Lonnie? Oh,
Yeah.
I got it
Hi,
very far.
Dr. Yang. I work at EPA, but I'm also a PhD student here at Maryland, so we should definitely connect. I also run the Risk Communication Action Work Group within EPA, so we have a senior risk advisor that's on our team, and I'd love to talk more about what you're proposing. But also, this work has really informed how we're trying to communicate and how we're trying to change based on the findings that you had. So I really appreciate all the work that you've done so far. It's really a tough thing to communicate. And, when you work for the government, you have lots of barriers to communicating effectively, like lawyers and policy and all kinds of people. So I really appreciate the work. And sometimes it has to be done on the outside. So that's all I wanted to say. Thank you.
Thank
Yeah,
you so much.
excellent.
Yeah,
Yeah, yeah.
I look forward to being connected and chatting with you more about this. I actually also serve on the National Toxicology Program and part of NIH and National Health and Human Services. And to date, being on the board only for 2 years, we haven't really looked at anything related to PFAS. But as I said, I feel like all the government agencies are just starting to really put our heads together and trying to figure out some ways to make sure we do it right, right?
Yeah, excellent. So, are there any questions? Other questions? Feel free to raise your hand. Okay, Margaret. Okay, Margaret, I'm gonna put you on the spot. Do you want to speak up here? You got a long question. I can read it out for you if you like.
I can talk. So I'm wondering, I'm also a student in our presenter's class, or not our presenter, our co-presenter's class. And we've been talking about, who feels that it's their responsibility to communicate science, and stuff like that. And I'm wondering, now that you've done your research about, how people perceive communication about this risk, what people know about this risk, stuff like that, where does the responsibility lie? have an obligation to continue your research further? Do you have an obligation to communicate it directly to governments or corporations? Can you leave this as you have done your contribution? I'm not sure like what the ethical implications are of what you've been working on.
Yeah, great question. Also a really big question. I've been thinking quite a bit about our role as scientists, right? And we do our studies in our lab and we publish our papers, but a lot of time it just ends there, right? But more and more, especially I think for the kind of work that Xiaoli and I do with risk and science communication, many of the things that we do have real world implications, and a lot of them are very important insights that I think we should try to get out there, right? So a couple of things I typically do is that, talking to the media, whenever I have a new article that comes out or getting a new grant, our university usually publish, some kind of public, press release to get out there. So when the media reach out to want to talk to you about what you found, I usually take those responsibility very seriously. I try to make time for it and really try to come up with key talking points that I really want to get out there. And also when press releases are written up about my study, I usually try to read at least, right, before it comes into print, just to make sure all the information gets represented accurately and responsibly, ethically. And then the other thing is that I have been very actively involved in, for example, the Society for Risk Analysis, where you definitely do have this interaction between scientists and policymakers and advocacy groups and people who wear many different types of hats, right? So over there, I think it's really important as well to communicate with other people about what you're doing, so that not only do they become more aware of it and potentially could also get collaboration or get invited to panels and this type of outlets, so that other people who might not work in a university or research setting could hear about your work. Reaching out directly to citizens, I haven't done that good of a job, to be honest. I'm not a social media avid user, and I don't necessarily push things out there on Twitter or anything like that. But I feel like maybe I should do more on that front. But in terms of obligations, for sure, I think it's important to continue carrying out the research, not only doing small scale studies like this, right? All the things that you see today, they're definitely more pilot type of work, right? They're not based on nationally representative samples, and they're all experimental. So, I mean, the first study was more experiment, second is more straight up survey. But like I said, the next step is I'm really trying to get larger grant funding to carry this work out among, more representative samples of Americans, for instance, or working with specific communities that have a higher risk when it comes to PFAS, right? So right now, what we're thinking about with the EPA proposal I just mentioned, we're looking into rural communities where PFAS actually is a really big issue because of agricultural water and also many other ways of exposure, both to animals and subsequently to consumer products. So grant funding is something I'm definitely very conscientious about, trying to make this work having greater impact, just like what I've done in my past research, to look at not only simple studies in the lab, but really the real world impact out there. Great question though.
Thanks, Janet. You talk about how you got interested in the topic. You mentioned this movie. Yesterday in my class, we were talking about entertainment education. In terms of risk communication and health communication, one of the more effective ways of swaying public opinion or influencing, our audience is maybe through entertainment media, not so much as, like the traditional health messaging. So I find it really interesting that you got it interested in that way. But I do have, I think it's a kind of a big question. So for me, as well as a health scholar, I mean, there are so many health risks in the world and so many environmental risks. There are all kinds of chemicals that make us scared. So for PFAS, how big a risk is it, right? So, I mean, we know like recently there's been coverage of like Coke, right? I mean, there's a Diet Coke or it's just some kind of chemical that is leading to cancer, right? It was a big story. Everyone got really scared. And then it seems like the message that comes out from the scientific community is like, unless you consume like 20 cans of Coke per day, you're not really at a risk of getting cancer because of that. So I wonder for PFAS or other kind of chemicals, I mean, we're exposed to all kinds of chemicals. I wonder like how big a risk? I'm sure there is some sort of risk, but is it the risk like big enough to, really justify a level of fear and maybe justify more funding or research or our attention? So how do you gauge that? How do you find the balance between the threat and the need for research?
Yeah, that's a great question. To be honest, I've talked to a lot of people who study the more health parts of it, right? So I think one thing that's really clear right now is PFAS has been strongly associated with a lot of reproductive issues. So, some of the things I listed on my slide. And also, so for example, pregnant women, obviously, it's a high risk population that we need to look at. And because PFAS can get through from the mother to the child, both internally and also through, breastfeeding and those type of behaviors. So I think for young women of, reproductive ages, this is something that they should probably be more, read up on a little bit more, talk to their doctors or physicians. I do want to say though, a lot of the health impacts, especially linking to kidney cancer, and, some of the other hormonal type of issues, the science is not 100% conclusive because it's still fairly new, right? It's relatively recent where we, the scientists and the researchers start to realize how prevalent it is. Like I said, 90% of Americans have in our bloodstream serum. That just sounds very scary. But for most people, it's not an emergent, it's not a crisis, right? It's not immediate. You're supposed to, it's not even a level of, causal connections like smoking to lung cancer, this type of thing. So I would say PFAS, it's important to do more research on because it's so new. It's almost like e-cigarettes to some level because it's fairly recent. We don't have long-term data to really establish, right, its connection. And also because we're talking about environmental exposure, as we all, like you mentioned just now, most of us are exposed to multiple things all at once, right? So it's also very difficult to really, separate out what is PFAS, what is all these other things that you might be exposed to at the same time. So I wanted to, if I piqued your interest about PFAS, there was an article in September that was published in the New York Times magazine and also New York Times main section focusing on PFAS. There's a lot more insights in there. One thing I noticed that I thought was really interesting is that after they presented all these potential risk factors, they said the CDC basically said it's not a emergency or it's not a crisis or something like that. So two things, right? So one, it could be confusing on some level, right? Because you just told me all these horrible things and I need to know more about PFAS. And then you tell me it's not something you need to worry about right away. So I think when it comes to reporting, when it comes to, media coverage, I think a lot could be studied about how it should be done. And then second of all, I think it's also very important, like you said, a lot of us probably feel that everything is risky, everything is something, but we can't pay attention to everything because it's too taxing, right? We can't simply be able to, we can't just, I can't check through all my cosmetics, my nonstick mascara to see if there's PFAS or anything like that. So I think government really should put less on the consumers and really should put more on the industries and the manufacturers, right? So for example, EPA already banned a certain type of PFAS, right? And PFAL, it's already gone. Like you cannot keep manufacturing, it has to be out. So I think a lot of those effort really has to be more on the system level change instead of putting too much on the consumers.
Okay, well, thank you. I'm getting rid of our microwave popcorns for sure.
That'll be a good start.
So Lani mentioned in the chat, and she made a really good point about it's a cumulative risk, right? So it's not like a one-time risk exposure. So like over a lifetime, how much you're exposed to, that can, kind of increase the risk. Gia has.
Oh, sorry. I just want to say maybe some simple things we can do, right? Get rid of your nonstick pans, for example, maybe order less takeout, right? Because all those wrapping things, the stain resistant, oil resistant, they tend to have higher level. But again, we can't get rid of everything. You still have to use your toilet paper. You still have to use your hygiene products. So yeah.
What do you use if you're not using non-sticking pans? I was wondering.
So the cast iron type of pans, right?
Iron
So as long as they don't have the
Okay.
coating, most of the consumer pans right now, they don't have the worst, right? So the Teflon is out, right? Those has been,
Gone.
yeah.
Right. Okay. Okay, Jia has been very patient. Go ahead.
All right, thank you very much, Dr. Yang. Finally, I got the chance to listen to your talk. It's very informative, and thank you for Dr. Nunn for putting this together. So one topic that in your talk that particularly interests me is the conflicting information and trust of science and governance, government. So my question is, I think the topic that you're studying is a perfect time or timing for us to look at the influence or how the conflicting information influence our trust for science or government or the other way. So I guess my question to you is, do you have an idea or a sense, a general sense about how people's general trust for government and science is going to influence their reaction to conflicting information? And also down the road, when people are exposed to conflicting information, how is that going to influence their trust of science and government?
Yeah, for sure. That's a great question. So I think two things I want to say immediately. Number one is that we all know source credibility is hugely important when it comes to any kind of communication and its success, right? So I think depending on where that information comes from. So for example, when we study conflicting information, right? If we pair, scientists versus agency versus whoever, right? So that source credibility is always going to be something we need to be very careful about, especially, given our political environment. And we know that in America, politics and science are forever intertwined. It's impossible to separate out the two, right? So for example, in one of the studies that we designed, we wanted to put the EPA in there to talk about this, water advisory level and whatever the information. And immediately we're like, some people just don't like EPA. So you can't put that in there because immediately they're not going to like this message and they're going to think you're manipulating my thinking or you're doing whatever. So I think it's very important for us to be very conscientious about it. Not to say it's not important to study, but I think when we say conflicting information, there's actually multiple layers underneath it, right? So, and how to define conflicting information is another part that's very important theoretically to parse out. Because are we talking about conflicting information in the sense that the information is logically inconsistent? Or are we talking about the information is being updated and changing over time, right? So for example, we all know, during the whole COVID situation with the mask mandate here and there, the science is evolving, which means the recommendation and the messaging is also changing, right? But some people can view that as a type of conflicting information as well. So to address that type of concern, I would say it's very important to maybe not just focusing on what the science is, but to really help citizens maybe incorporate into K-12 education to really help people to have this scientific way of thinking, to understand that science itself is uncertain, it's developing, right? There's this constant evolution going on, which means old knowledge might be completely eradicated or completely falsified. Or so I think obviously conflicting information is a very interesting topic, right? A research subject or area, but I think we need to be very clear about which layer do we want to tackle, right? Maybe not all at once because it's all very complicated, as I'm sure you know. But in terms of trusting science and government, right? Like I mentioned, even though we know overall public trust is declining, right? But I think a very maybe positive or silver lining is that generally people still tend to trust science and scientists more than government and agencies on a very general level, right? Just for American public. But then the last thing I want to say, like I talked about this role of politics, right? So I think it's also very crucial for those of us who probably belong to one particular camp now to try to own science, right? Because science is not just liberal entity. Science is not just what the people in the university and people on the left care about. I think if we give science this very political spin to it, it's actually more damaging when it comes to public communication, right? Because science does not belong only to the liberals and people on the left. It really should be something that everybody should try to incorporate in their decision-making process. Sorry, that's a long-winded answer, but I'm very passionate about this subject, so there are a lot of things I can say about it.
Yeah, no, thank you so much.
Thanks, Janet. So we have quite a few students in the audience today. There are undergraduate students, some are from a health comm class, and they're aspiring health comm communicators. And there are also graduate students who are doing health comm, risk comm research. Do you have any words of wisdom for these two groups of people? For undergrad, if they're thinking about doing health comm or risk comm as a profession, and for grad students working on health comm or risk comm area, like you've been very successful professionally. I think you're the right person to ask this question. So just maybe a couple of advices for them. I think that will be very helpful.
Sure. Thank you. I think based on just my personal experience and also working with many students over the years, I think it's really important to work on the things that truly interest you, not because it could give you another publication or just to put another line on your CV, right? What I mean by that is, I think we all know our field is just getting over amplified when it comes to publication numbers and productivity, right? Students who are graduating today have 6, 7, 10, 12 publications, which was unthink of in my days, right? So I think a lot of the time we're very tempted to put more numbers in our Vita without really thinking about what we're doing, because that's the culture, and it's good or bad in a lot of different ways. But I think for students in this particular area, because there are so many things we can do, right? To give you an example, I think my very first NSF grant was related to Ebola, right? Some of you probably remember that a decade ago. I literally cannot stop thinking about it. I woke up at 3 a.m, just keep thinking about Ebola and where it's going. Is it going to get a lot worse? Is it really going to become, a pandemic? So I literally wrote that proposal overnight, and it's a rapid funding mechanism that NSF offers, which is a short proposal. It's not a full length, which was really why I literally finished it in 2 days and got awarded in a week, right? So I think that's the kind of passion that really drives you and really motivates you. So I feel like those of us who are very lucky and fortunate to realize this is the area that makes you lose sleep and you can't stop thinking about it and you just have to do something about it. Don't give up on those ideas. Even if you're not immediately successful, keep at it, because I feel like that passion and that genuine care for a particular research area is really going to give you long-term success instead of just immediate gratifications. So hopefully that's, maybe not the most practical advice, but I think something that was really important to me.
Wow, that is actually pretty practical in some way. And I've always been telling my students, both graduate and undergraduate, is that, this might be the best time to be doing health comm research or risk comm research, because all the, I'm not happy about the pandemic, but it happened. But especially put our kind of research to, on the spot and make it particularly relevant. And also given the communication technologies that have been evolving, where we can communicate more about health and science. So that was wonderful. Thank you so much, Dr. Yan, for this really informative and very rigorous studies that you've presented today. And thank you to the audience for attending. We hope to see you next time with our next seminar series.
Thank you so much for the invitation.
Thank you.